Perfect. Okay. All right. So yeah, I guess you can keep looking at that, but or maybe just stop and give it a second here. And then I actually have something else I forgot to put here. Um, you know, the idea of vertical angles, which I think maybe we already have discussed that too. So why would just picking two things? Why would angle two be congruent to angle three? It's because they are vertical angles. So remember that idea too. That's a huge thing in getting all those other um, angle measures in that one drawing that I asked you to look at in the first place. And there's a whole bunch of pairs of vertical angles, but I just happen to pick these two. So vertical angles are congruent. So 2 equals 3, 1 equals 4, 6 equals 7, 5 equals 8. And I believe we have had that before, but maybe I'm thinking of my CAD class. So just wanted to make sure I stated that. Hopefully you recall that from basic geometry. And I always tell people to cheat. What? Okay, so let's look at like angle 2 and angle 6. Everyone get ready with the 3, 2, 1. What does angle 2 look like? Acute or obtuse? 3, 2, 1, go. Acute. What does angle 6 look like? Acute or obtuse? 3, 2, 1, go. Acute. So they're both acute. There's a good chance that they're equal then. And that's what I tell them. And then hopefully you can remember this term. They're equal because they are what's called corresponding angles. They face in the same direction on the same side of the what this is called a transversal, one line that cuts two other lines. Oh, these two lines have to be parallel. Add this to the drawing. This is what parallel means when you see it in the picture. They put an extra arrow on both of those lines, like somewhere in the middle or somewhere in between the arrows that mark a line or create a line. Lack of a better way to say that. Well, then when you look at 4 and 6, 6 is acute. What does 4 look like? 3, 2, 1, go. Obtuse. Could an acute equal an obtuse? Yes or no? So why would we set these equal? They're not. They're actually supplementary. There's very easy conjecture of how this is the case. If 6 and 2 are equal, that's great. 2 and 4, what do these add up to become? 3, 2, 1, go. 180, we should know that, all right? This is a straight line. All lines are straight, but anyway, half of a rotation is a 180. 360 is a full rotation. We'll talk about that later when we start doing trig, um, of angles greater than actually even 360, which is kind of a weird concept. But we should at least know these are 180. So if these two are supplementary and these two are equal, then these two must be supplementary. That's kind of like a transitive property of, making a connection there. If I have that term correct, I was kind of a little lax on my geometry terms and logic, I guess. So all these other ones, the same thing. Look at 4 and 5. They both, and this is only if the transversal is very slanted. Then you can kind of cheat and say, all right, these two look obtuse, so they should be equal. But they're alternate interior angles, and they definitely are if the lines are parallel. Alternate exterior, these two both look like they're obtuse. So I think they look like they're equal, and that you'll survive with that. These two on the other side, I think this is 2 and 7, are equal as well for the same reason. They're both acutes. So I kind of let students kind of, cheat on that so that they can make this pretty easy. All right. So looking at this in the warm up real quick, um, because both of these angles are right and they're cut by this transversal, then there is a theorem that says you can say these two lines must be parallel. They must be going in the same direction. So when you look at this first comment, why is WZX? And unfortunately, my daughter is in geometry. I told you that story before. And unfortunately, she does. You guys did proofs last year, right? Given, and then you have statements and then reasons on this side. She had like 10 to 12 step proofs she had to do this year. Those are kind of rough. Fortunately, we're not going to do that with you guys, but there is something that she would have to say in her proofs. Why are these two angles congruent? Because all right angles are congruent. That's a theorem that you would literally have to write. So she wouldn't be able to assume these are equal. She'd have to write it that this angle is congruent to this angle. Notice that measure of and measure of, now we have an equal sign. I kind of talked about that with geometry semantics in our previous notes. So we're not going to write it in the sense of the theorem. They are both right. What my daughter would have to write is these two are congruent because all right angles are congruent to each other. So the term of being right angles. And then in proof making, why would WXZ, remember how we could mark that now, this arc is equal to this arc, and that's how I could mark two angles as congruent. They both have a single little arc mark there. Or if you want to take it a step further, arc with one tick mark, and arc with one tick mark. So I was talking about that with our geometry remembrance of stuff. But why are those two congruent? Again, my daughter would have to say this angle is congruent to this angle, and then in the reason section, she would have to write if two lines that are parallel are cut by a transversal, then which of these four do they represent? Is it alternate interior, exterior, same side, or corresponding? 3, 2, 1, go. Then corresponding angles are congruent. So that's what she would have to write. And maybe you went through that last year. Because I'm just going to say they're corresponding angles, though. I'm not really big on the proof making. I do understand the logic. Sometimes they can be very picky. And I think my daughter is in a very picky class where so many things have to be written in the proofs that she gets dinged a lot. It's been a bit of a struggle for her. Okay, so now looking at this drawing super fast because I don't want to take too much time on this, but this is really a main idea of how this is going to affect what we do later, these ideas of these angles. But this is what you have to do. You kind of have to focus on just certain parts of this. So I'm going to highlight that first. And now what I see is I have two parallel lines, and this is the only transversal I care about for a second. So why am I going to make this 85? What are those two angles called in relation to those terms up there? 3, 2, 1, go. They're alternate interior angles, and alternate interiors are equal when the lines are parallel. They must be parallel. And by the way, there is the mark for parallel right there. It's these double arrows. So sometimes it could just be one arrow. I'm surprised they have two arrows on that. They don't need the two, but it at least shows that they're parallel. So I'm allowed to do that. And then same thing on this other side, this line, but now concentrate on that transversal, the other one. So same reason will make you say it. These two angles are congruent because they are alternate interior angles with those two sides being parallel. Have to be parallel for this to be true. Not parallel, then not true. Now you got a whole bunch of stuff here. These angles are going to be congruent to each other because they're vertical, and now I can do 180 minus. What does that angle measure when you do 180 minus 85 minus 32? What do we get? 3, 2, 1, go. 63? Is that right? And now you could almost get every other single angle measure through 180 minus. Because this is 32 here, I'm not going to mark it. And then this angle right here is 180 minus 32, whatever you get there. This angle is 85. These two angles are whatever 180 minus 85 is. This angle is 180 minus 63, so you get those two, and then it just, everything takes care of it all the way around. So vertical angles, and then 180 minus for straight angles. That's why you're both, able to get all of those. Okay, so basic geometry. One other thing, this is why we did the factoring, and then reminding you about solving by factoring. And I'm glad what happens on this happens. You don't know that yet if you have not started, but go ahead and try to solve that real quick. I'll give you a minute so that you own your notes again. And hopefully you remember when you have fraction equals fraction, what the method for solving what would be best. You get out here? Everyone's came in and did make the seating chart. Okay, and then I had that factoring sheet, but then lo and behold, we get the type of factoring that students kind of struggle with right off the bat there. So let's move that together. And then Nicole, we knew about Nicole. Nice. Only one absence and doing well with attendance. Hopefully we're rolling back to getting normal here. All right, I'm gonna freeze and then just reveal. Raise your hand when you get an answer. Anyone done? Not yet. By the way, what is the first type of factoring you should remember and always look for? First thing you should always look for, which is not on our sheet Monday. 3, 2, 1, go. GCF, right? I believe that happens in this if I remember what I looked at yesterday. So that should give you a hint how you solve. I think froze. Okay, let's cheat. We're gonna cheat on here. Just double check. Where did it go? Oh no. What? Did I have that in there? No way. Yeah, I guess I have to solve it. Losing my mind here. Oh, oh, there it is. Yep, there we go. Okay, and then how many people have an answer? Raise your hand. Nobody? Nobody knows how to solve this? Nice. I guess I have a purpose here. All right, so when you have fraction equals fraction, you should have cross multiplied. That's how you start this off. So you multiply this times this, and that equals this times this. Did you guys start with that? How many people started doing that? Oh, no, you don't remember how to do that. Okay, maybe we've never seen that before. Okay, so then let's treat this as a note thing. All right. So that's what we should have done first. Whenever you have fraction equals fraction, you can cross multiply in order to solve. So x times x minus 6 equals 2x times 12. All right. And I know I can't really I tell you another method because I think you're going to do that in Math 3 when you have really complicated fractional equations. I'm pretty sure you wouldn't have seen that in Math 1. So fraction equals fraction, cross multiply. Problem is then you have to distribute, so it's not quite a FOIL, multiply, and then get everything on the same side. Now we're in the quadratics of solving, which is what we kind of started the year off with. We had questions like this in the second chapter, I think, that we dealt with. I'm trying to think what we had solving. Maybe it was the first one. No, when we get probably maybe second or third, so September, October, we solve these kind of things. You have to subtract 24x, then factor. Okay, but that's what I was talking about here. This isn't the factoring MA or whatever. The first thing you look for is there a common term that I can pull out? And there is. Remember, this is undistribution. That's GCF factoring. Again, this is why I said every week from here on out, we're probably going to at least factor once, twice, 3 times. So factoring by solving, or solving by factoring, definitely a thing. And then this is ZPP, which is zero product property. Either this equals 0 or this equals 0, and then you solve. So x minus 30 equals 0, you get x equals 30. Now, why did I cross off 0? I don't want to bore you with this because I don't want to run out of time on our notes, but you cannot plug in 0 back into this equation because it doesn't solve it. You can never divide by 0. Go ahead on your calculator right now and type 12 divided by 0, and what's the calculator spit out at you? Undefined, right? Doesn't work. Divide by 0, error. All right, so even though you got x equals 0 as a solution through valid math, That's what an extraneous solution means or is. So extraneous, and we did talk about that when we looked at um, our solving unit. I don't know if that happened. I think it happened when we were solving maybe some absolute values. I know we had the term extraneous solution before. What it really means is it's a solution that you found legitimately, but it actually doesn't work. All right, and that just happens sometimes in math. Okay, so anyway, funny. I thought we'd have a lot of people remembering how to cross multiply a fraction equals fraction equation. Okay, so we'll treat that as kind of like a solid note chunk there that you need to get down. All right, good to know, good to know. This is going to happen a lot now with similar triangles, by the way. Okay, so now going back to my notes. If I def flip all the way to the beginning here. Okay, so I solved that. All right, now we're getting into this. And this is going to be flat out, all right, this is what you need to know. And hopefully last year you dealt with equal triangles. Two triangles are equal if side, side, side is true. Do you remember this? So there's side, hopefully I remember all these things. Side, side, side for sure, for equality. Side, angle, side, right? And the point is, if I have two triangles where side, angle, side is equal to side, angle, side, then all of the parts are equal. So we can assume those two triangles are completely equal and then do things from that. So side, 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 angle, side, angle, I think was another one. And now hopefully I'm not not forgetting any. Fumble. Was angle, angle, side one? I think that might be one as well. Angle, angle, side. I don't know if that one is one or not. My geometry's a little, I haven't taught regular geometry in a long time. But then when you get to right triangles, you remember hypotenuse length, HL, right? Okay, so just kind of reviewing, that's when triangles are equal. Well, these postulates are proofs when triangles are similar. So this is definitely not a shared equality thing. And notice this symbol, and you might want to highlight this. That symbol right there means similarity, that little squiggle right there. So this is the angle similarity um, theorem. I should call it theorem, probably not postulate. If two angles of one triangle are congruent to two angles of another triangle, then we can assume that the triangles are similar. And we have to remember, what does it mean to be similar from our 2 days ago in this class notes. The angles will be equal, but the sides will be proportional, not equal. So that's why we had to solve that proportion up there. So remember that from 2 notes ago. Oh, heck, I guess I could kind of look at that real quick. Ding, ding. Let's get the ones that we had right here. It was this one right here. So remember our notes from 2 times ago. If two figures are similar, the angles that correspond are equal, but the sides are proportional. They're not equal, they're proportional. All right, so try to remember that as we move forward here, what's important. Ooh, I forgot to do something here too. Let me copy and Control V. Just have my notes ready for the other class. And then it throws me back up to the top of the page. Okay, so how do I have angle when nothing is marked here? Well, if this was a geometry proof, the first thing we would have to write is angle ACD is certainly equal to BCE. What would be the reason? Because they are what kind of angles? 3, 2, 1, go. Vertical, or you'd say vertical, all vertical angles are congruent. Then we can make a choice. I'm going to do the highlighting yet again. We only need one more set of angles to be said to be equal to each other to get AA. Because I have one set of angles congruent, that's one of the A's. Now I need another one. So I chose to highlight this and then mark these 2 angles as congruent. And this is another way you can do it. So I keep flip-flopping back and forth. How can you mark angles congruent? I could have done 1 arc with 2 ticks, or I could do 2 arcs, just so you recognize that notation. Now, why is DAC, and I should be writing this, by the way. And we're going to be real short on our, we're not going to make this like Sammy Samuelis has to do. So let me write that first thing. Angle ACD is congruent to angle B, which I already have, angle BCE. Then I'll be real lazy on this. They're vertical. Okay, and vertical angles are congruent. So we're not going to do that whole proof thing and all that writing. And then angle DAC for sure. And remember how to name angles. The vertex must be in the middle. Angle B, oh my gosh, BE. Is that student okay? Is everything all right? Yeah. Oh, did you throw it in violence or no? No. Man at the notes? Okay. All right. And then what's the reason? Here we go. And I might make you write these reasons. What kind of angles are those? 3, 2, let's hear what we say here. 3, 2, 1, go. They are alternate interior angles, and these are marked as parallel. So Sammy Samuels would have to say these two angles are equal, and then she'd have to say if two lines that are parallel are cut by a transversal, then alternate interior angles are congruent. She'd have to actually identify that and write that statement. So alt interior, we're going to be lazy. Sammy Samuels probably wishes she would be in this class right now because she can't stand proofs. Hates them. Anyway, similarity statement then is the following. You got to get the angles that correspond to each other. So the triangle, and then the first choice is up to you. DAC, and then here's the similar symbol. It's that little squiggly, so that means is similar to. All right, so who goes with D? The unmarked angle over here, but I could have marked them. Definitely same thing. These are alternate interior angles too. But you only need two angles noted as congruent for the AA similarity situation. All right, so who goes with D? B. And then who goes with A? My pen's really being jerky here. E. And then, of course, C goes with that. And then you could go and do a whole bunch of other stuff. You could say that AC over CE equals DA over BE, which equals DC over BC. Notice I went left to right on all my fractions. You got to go in the same order when you set up those similarity statements. Okay, next one does coincide with the SSS equality of two triangles. But in this case, SSS similarity has to be that all three corresponding sides of two triangles are not equal, they're proportional. And if that's the case, then the triangles can be said to be similar. So what you need to do is prove this. Okay, so how many are going to surmise when the question is like this? Probably, maybe I'm wrong, I'm going to try 8 going with 20. Because you probably have a similar situation where even though these are not marked as parallel, if these are truly proportional, then this probably goes with this. This angle is equal to itself, and probably these opposite corners are equal because the alternate. But you don't know that yet until you find out if these sides are similar. So more than likely, 6 goes with 15. So we're going to check that, and I'm going to make up a new symbol. It's equal question mark because I don't know if they are equal. I'm checking that. And then notice I went top to bottom. Silly mistake students make is they write 6 over 15, then they go 20 over 8 as the next fraction. Why would you do that? Go in the same order. First triangle on top, second on the bottom. First over second, first over second, first over second. And we're going to check, does 8 go with 20? We might have to reverse this. 8 may very well go with 12 and a half. So my first check is going to be this. If this checks out, I'm good. If not, then I'm going to try 8 over 12 and a half and 5 over 20. But I already know what 5 over 20 is. That's a fourth, and this certainly is not a fourth. So that's why you can make educated guesses here. So 5 probably should go with 12 and a half. And then you probably want to go to your calculator on this because of the 5 over 12 and a half. I was going to try to be fancy and do my reducing of fractions and all this other stuff. So let's wait an hour for my calculator to open up. You guys can go ahead and type what's 6 over 15, what's 8 over 20, and then what's 5 over 12 and a half. There it is. That's how long it takes to open. It's always so much fun. Okay, so 6 divided by 15, right? 6 divided by 15. Enter. 8 divided by 20. So far, so good. And then 5, was it divided by 12 and a half? That was the only one that, reducing the fractions with that decimal, boom, boom, and boom. Okay, so you ended up getting 0.4 is equal to 0.4, which is equal to 0.4. So the question mark is gone. It's satisfied. So what Sammy Samuels would have to say, and I should say this at the end, these are similar by a similarity. Obviously, that's the column that we're using on this one. But now that we have that, order of the triangles. Triangle, first one is up to you, LMN. So you're not going to be wrong if you went MLN. But what you will be wrong with is the next triangle, who goes with what. All right, and then it's the same thing as this previous question. It's exactly what I thought. All right, so the angle opposite 8 corresponds to 20. So these two angles, is that a P? I guess that is a P. NOP, yes. Okay, so who goes with L? O. Who goes with M? P. And then who goes with N? Of course, N. And then you say by SSS similarity. You got to prove the proportionality, though, in order to support your idea here. Then the last one, this is a common drawing that we're going to need to understand here. SAS. Now, are these marked as parallel, yes or no? So you don't know they're parallel. Just because they look like they might be, geometry, there's a rule. Never assume anything in a drawing. There's only one thing you can assume. The line is straight. So if I had something that crossed through here, you can assume that these add up to 180 degrees. So you can assume a straight line. You cannot assume a right angle, and you cannot assume that these are parallel. Okay, but here's the problem with this drawing, and we really got to mark this up with your highlighter. What we're going to try to prove is that this triangle, the small one, is similar to this big one. All right, so that's the idea here. That's what you got to be able to separate. And you got to be able to think about these as taking out as two separate triangles and looking at them. All right, because obviously this angle is equal to itself. So Sammy Samuels would have to literally write angle Q is congruent to angle Q. And I guess she would say all angles are equal to themselves, which I think is one of those, I think that, I forget what word it is. There's reflexive property. It's not that one. I can't think at this point, but that's what she'd have to write in a proof. She'd literally have to have that as one of her steps. But then the next thing is, how do I prove the sides? Well, who does 10 go with? And then the instinct is to say 5, but that's not this whole side. What is this whole blue side right here? What is that equal to? 3, 2, 1, go. 15, only 2 or 3 people said. Come on, you got to add those 2 to get that whole length. If this one's 10 and this one's 5, this whole blue side is 15. Does that equal, question mark, 8 over 8 plus 12, I'm sorry, 8 plus 4, which is 12. Same thing on that one. So that would be side, angle, side, angle, side, for that. 2 corresponding sides of 2 triangles are proportional and the included angles are congruent. Okay, 10 over 15 is 2/3, 8 over 12 is 2/3. So that question mark is gone. This is true. Okay, so the proportionality is true and an angle is equal to itself. So therefore, these 2 triangles are similar by side, angle, side. Okay, so triangle RQS, much easier probably. Nothing tricky about this after you get that figured out. Triangle TQW. Sure, it's in this column, but this is what you state at the end. Wrong. Sorry. SAS, similarity. Okay? So specific to triangles. And actually, that's what our world is stuck in right now. We're taking triangles all the way through for the next couple weeks when we do trigonometry and all that other stuff. So it's triangles, triangles, triangles now, not just general similar figures. Identify each statement as true or false. Explain your reasoning. Okay. Kind of read those and maybe tackle those on your own, even though we only have 12 minutes left, so I really got to get going here. All right. That the measures of sides of one triangle are 5 times the measure of the sides of a second triangle. The two triangles are similar. True or false? If you put true, which postulate is in action of those 3 that we have up there? If it's true, then which of the 3 postulates or theorems, I should be saying? The theorem has to be proved. Postulates are accepted as truth. Sometimes they're postulates, sometimes they're theorems. Little semantic. And then the next one is 2 triangles are both right triangles, then the 2 triangles are similar. Okay, and then because we're short on time, true or false? Number A. Number A? All right, anyway. 3, 2, 1, go. True or false? True. That is, by statement, the SSS similarity. Okay, that proves that they are proportional, and that's what you need as one of the theorems that proves 2 triangles are similar. So this over this over this, and this over this would all equal 5. That's what the scale factor would be called, actually, too. We can use that from our previous stuff. Letter B, true or false? 3, 2, 1, go. Not enough information. Is there just an A similarity postulate? No, there's an AA. There's nothing that says what the other 2 angle measures are. All right, and they don't give you any information about the sides. So not enough information, that's a false. All right, moving on. Here's what your homework has to look like and what you're supposed to do. I kind of like the charts here. All right. And then support what you have to write on the test, which these kind of coincide with the ones in the chart here. So number 1, why are they similar? Which of the 3? 3, 2, 1, go. AA. Ooh, we're not really talking much in this hour. So the support says that angle N is congruent to angle X. This is what you write. And then angle T, you're just proving that you know what those symbols mean, meaning that the angles are congruent. So the theorem is the AA postulate, or theorem. Got to stop saying postulate. It's just stuck in my brain. And then your statement, the order of the letters, which I've said for like the 3rd time. I'm going to check that your order is right. Again, your first triangle could be MTN. There is no rule about what you name the first triangle, but the second triangle is stuck. N must go with X. T must go with Y in the same position. And then B, XYB, that's weird, must be where M is. So if you said triangle MTN, then it'd be triangle BYX. All right, and that's what we got to make sure, and that's what I'll check. All right, support for this is not just saying they're proportional. You prove it. So usually, if the drawings are just like this, the numbers go right with each other as they look, but it should be simple. 18 is the smallest number. 24 is the smallest number. 18 should go with 24. All right, so we got to check with our question mark thing. Does 18 over 24 equal? I love the question mark equal sign. Use it. 21 is in between. 28 is in between. So yeah, 21 should go with 28. And then equal, maybe, 33 and 44. The 2 largest sides being compared. 6, 12, 18, 24. These are all equal to 3/4. 21 or 28, 7 goes in each one and ends up with 3/4. And then this one, 11, goes into both of these and ends up being 3/4. So you can say 3/4 does equal 3/4, which equals 3/4. So this is yes by SSS, similarity, and then the statement would be CAB. Very simple. These are in order. There's no flip-flopping. Is similar to FDE. So establishing that they are similar, then we can move on. 827. Okay, last one. I don't have time to write this down. SAS. But you have to prove 28 over 16 does equal 21 over 12, and it should. Okay, so I got to move on. I think we understand the whole idea. All right, and then definitely I know how the test looks. I got questions that are exactly like this. So probably only have time for a couple of these. All right. So looking at this, are they similar? You may get a no on this. All right. And again, I'm going to kind of speed this up here so that I don't run out of time for our solving section. So hopefully you know how to cross multiply now, because that's how our notes are going to end as I get this last part. But looking at this triangle, these are kind of rotated a little bit. So they're not exactly lined up perfectly the way I like. But 8, 12, and 15, 8, 10, 15, 20, 8 has to go with 10. The smallest with the smallest. So we're going to try side, side, side. 8 should go with 10. 12 in the middle should go with 15. My pen, it's so stupid. All right, and then 15, this 15 on the right should go with 20. And notice every single time I went left to right equals left to right, which equals left to right. In the order here. And then I believe 4 goes into, or 2 goes into both of these. You end up with 4/5. 3 goes into both of these, 4/5. 5 goes into this, 5, 10, 15. Wait, 4 goes into this. Hold on a second. Is this true or false? So 2 goes, I better write this. This ends up being 4/5. 2 goes in 8 4 times. 2 goes into 10 5 times. Does that equal? 3 goes into 12 4 times. But then this last one, 5 goes into 15 3 times. Oh no. Is this true or false? All 3 of these being equal, yes or no? No. So there is nothing. They are not similar. SSS did not quite work out. So there is no similarity statement. Ooh, I was about to jump the situation here and assume that I thought that they were, and that's the point of this. Okay, so thoroughly checking this out. Running out of time here with 5 minutes. Are these two similar? Yes or no? 3, 2, 1, go. No. You have side, side. So if this was 5, this was 5. If this was 10, this was 10. So 5 over 10 equals 5 over 10. You can pick numbers, but there's nothing to say that those two angles in between are equal. Those could be toggled in any way, shape, or form. This could be 100 degrees. This could be 50 degrees. So there's nothing here. So I don't have SAS. There's a no. There's nothing really to say there. Nothing to support that those are congruent. I'm sorry, similar. Then the last one, and then I'll get to maybe some proportion solving here. Hopefully, I guess I do end with the homework being a lot of proportion solvers. So we only have one situation where we have that happen. So I might have to jump to the homework real quick. But we know these two angles are congruent. We're not doing proofs. You have to write that this angle is congruent to that angle because they're vertical. We want to check the sides now. So again, normally when triangles are like this side does go with this one. So I'm left to right. I'm going to do 9 over 12. 3 times. Does that equal 9 over 12? 18 over 24. Then my reducing. 3 goes into both of these. 3 goes into 9. 3. 3 goes into 12 fourths. So 3 fourths, 6, 12, 18, 24. Same thing, 3 fourths. So the theorem is proven for SAS. They are therefore similar. And now I can write my similarity statement. Okay? All right. So let's get that written real quick and then clean this up. I'm going to go this way. RPQ. So triangle RPQ. If you've already started, you just finish it off with your names, with the letters in the correct order. So of course R will go with R, right? And then who is equal to P across the way? It's T, and then S. Oh my goodness, that was fun. All right, and then what I'm kind of short on the notes, if you flip to the homework, and actually I'll probably grab a sheet on this, but hopefully you survive on this okay. No, actually I just have solving proportions there, so that's good. So a couple more, just these not tied to a drawing. The ability to cross multiply and then solve by factoring possibly. It doesn't always have to be solving by factoring, but it may end up being the case. Okay, then as I blabber, here, we'd have to use 180 minus to see if these angles, what those angle measures are, and then possibly that could be AA, right? This one, this angle is equal to itself. This again would be this triangle. Try to prove that is similar to that, just like, where's my highlight? This example right there. So they're attempting to see, does SAS hold true for that? And then the last one, just to complete the notes, with those lines being parallel, first of all, this angle is equal to itself, and then corresponding angles are equal. So yes, the top triangle is similar to the whole triangle. So again, it's this triangle is similar to this triangle by AA, because these two lines are parallel and there's that marking for that. So that angle is equal to itself. These two angles are equal. I know these two are equal as well, but I only need two sets for AA. I don't need all three. All right, so good. That should be enough.